Hi. I want to keep working on u-substitution with you, a technique in integration for undoing the chain rule. That is to say, we're trying to integrate functions which are the derivatives of compositions of functions. I talked about a general method for doing this in another video. This one, I'm focusing on how do we figure out what u is so that I have a sense of what to do in these problems. Because the first steps to doing these is to kind of poke around and identify that u-substitution is a good candidate for doing the integration. My general advice is to let u be the inside function, inside the more complicated part of the integrand. And so I put 4 examples on the board. And I wanted to talk about finding u for each of them. Let's start with the integral of 5 minus x to the 11 dx. I see something to the 11, and on the inside, I've got this linear function. And when I take the derivative of a linear function, I get a constant. And so there's a way that we can introduce constants if we need. But I think the right thing to do here is to let this right here, we're going to let that be u. That's going to make u equal 5 minus x, which means that du is equal to minus dx. I'm using the, skipping the step where I would have du dx equals minus 1. And I'm just going to go ahead and move that dx because I'm going to do it every time when I'm figuring out what du is. So I'm just going to skip that step. I'm going to take the derivative of this and put it in front of the dx. So du is minus dx. So if that's u, then in order to get du to show up in here, I'm going to multiply by minus 1 in order to make that happen. So this is a minus parenthetical, so I'm not subtracting dx because that doesn't make any sense. So I can introduce a minus sign by multiplying by minus 1 and putting 1 on the outside and 1 on the inside, which is a really common technique. So u is 5 minus x for this problem is a good choice. Let's take a look at this one. Think about that problem. I've got, let's see here, in the denominator, something to the half. That seems complicated. And the thing underneath it is x cubed plus 4. And when I take the derivative of a cubic polynomial, I get a quadratic. I've got a quadratic upstairs. I don't have any extra terms. If I take the derivative of 4, I get 0, so that's cool. And if I take the derivative of x cubed, I'm going to get 3x squared. No problem at all. I can get 3 just by multiplying by a fancy 1. So I think u should be the inside function. I've got something to the half. So my gut is telling me to put that equal to u. So u is equal to x cubed plus 4 means that du is equal to 3x squared dx. Still skipping that move the dx to the other side step. Okay, so this is another example where I'm kind of like off by a constant factor, but that's okay. You can introduce constant factors. You can't introduce non-constant factors, just constant factors. And so in order to put a 3 right here, I need to put a 1/3 outside because 1/3 times 3 is just 1. So I didn't quite do anything. So now this part right here, this whole thing right here, 3x squared dx is what we call du. I guess I could write down what it turns into once I do the substitution. So this one turns into 1/3 of the integral of du over u to the half. And this is basically a trivial function to integrate. I just use the power rule because it's u to the minus a half du. You just use the power rule. This one, it turns into minus the integral of u to the 11th du. Because here I have that part right there is du. Okay. So u is the inside function. Let's do it for these two problems here. This one right here I selected because just by looking at it, it doesn't so much look like I need to use u-substitution. And depending on how comfortable you are integrating functions like this, maybe you can just skip because there's a pretty easy pattern once you see it for doing these types of problems. This video is not about that pattern, so I'm not going to give it to you right now. Instead, I'm going to say, oh, I've got 2x inside of here. I don't know how to integrate cosine of 2x, but I do know how to integrate like cosine of u. That's no problem. And so I think this part right here, it's the inside function. I'm going to let that be u. So u is equal to 2x. So what's du? I'm going to take the derivative of this, and I'll have that du is equal to 2 times dx. I need to get a 2 here with this dx. So I'm going to multiply by 2. That's multiplying by 2. And I'm going to multiply by a half on the outside. So now I have 2 dx. That's du. And this function turns into a half of the integral of 5 cosine of u du. And now I know how to integrate cosine of u because the derivative of sine is cosine. And so this is just using the basic formula for integrating cosine or sine. I really like this last one here. I chose it because I find that my students have commonly struggled with these in the past. And so I wanted to be sure to include one of these problems. I think the point of subtlety on this one is that there's like this over x here, and it's like, okay, fine, like should u be x? No, because then du would just be dx, and that wouldn't help me at all. Remember, we're going to let u be the inside function. We're going to be so I've got something cubed, and we're going to ignore that part down there. So this part right here, I'm going to let that be u. Because then I'm going to have u cubed, no problem. I know how to integrate u cubed all day long. So if u is equal to natural log of x, then du is equal to 1 over x times dx. So here I've got 1 over x dx. So that when I do the substitution, I get that this is equal to the integral of u cubed du. And then I would just use the power rule to finish off that integration and then unsubstitute. Let's try letting u be the inside function. And I would just like to emphasize once again that you gotta be willing to just try and see what happens when you try letting u be various things. If you're able to consume the entire integrand in terms of numbers and u's, then you're on the right track, because then we'll have something that is like hopefully more basic, and then I can be able to integrate it. And if you try the wrong thing, then you probably won't be able to do the whole transformation to get the function entirely in terms of u, and you'll have some like x's left over. And I don't know how to deal with things when they have x's and u's in them. That's my advice on identifying u for u-substitution. Keep trying problems, and you will succeed. Thank you so much today, and I'll talk to you again next time.